Hey there, my name is Max, and well, basically, I want to start a small fun project for myself right now, which will give me a lot of opportunity to, test out some new things that I haven't been able to work with, as well as practice on some of the things that I already have. And the project that I decided to do was to build a Reddit clone. And well, I thought it would be fun to kind of just share this whole process because I think for some of you who are maybe, new and are getting into it, it'd be interesting for you to see some of the stuff about, how it goes on, the different planning, the programming, how long different things take, what you're actually doing. And well, for those of you that have been programming for a while, hopefully you can give me some feedback on some of the decisions that I make so that I can also improve myself. And yeah, I mean, generally about this, and you can see I actually already started this yesterday. I started like planning out the architecture and everything, and I'll just kind of walk through in a second where everything is currently at. But yeah, generally what I think how this is going to be going is first I'm going to do some architecture planning just to make sure that, the system has a good foundation that can scale relatively well, or at least, thinking about some of the, not immediate, but, a little bit into the future, even though they may never, they're not going to affect us. But, trying to treat it more like a real project. So thinking about some of the scaling, some of the data models, how we can treat different things, what kind of edge cases we may be running into so that we can be prepared for that to make sure our solution, works in those cases, or even if we didn't build a solution for it, our system supports being able to do some sort of scaling out to help deal with high load situations. Then after that, it's going to get into, part of that will also include like API design and stuff like that, writing out the endpoints, or at least what we expect from them. I definitely believe this is going to be some sort of iterative process. Obviously, I want to have as much planned out beforehand to make sure that everything is there. At the same time, I don't just want to spend a lot of time planning and not actually coding, because obviously I want to practice all of these things too. And then, yeah, we're going to go into the coding. So mainly I think I'm going to work with Flask and a Fast API, but I've also recently started doing a bit of Go. So maybe, if if time allows and everything, I'll also be doing some Go stuff. Because this is also a learning project for me, you're also going to just see me doing a bunch of research, as you've already seen here. Part of this is like natural. So generally when I'm planning projects, I always do research because, well, I may have read something at one point that I vaguely remember, but I don't fully remember it. So I'll try to find information like that. Aside from that, if you have a new problem, it's generally good to get kind of a basis of how others have been treating this problem so that, you can do everything well. So yeah, I think in this case though, I will be doing more research than you probably would, because there are a lot of things that, I haven't necessarily needed to build fully myself from scratch. So I'll be doing a lot more research. I think part of that will be on stream. Other parts I'll just be doing offline because I don't want to bore you with all of that. But yeah, that's kind of generally the plan. I have no idea what to expect from this. I don't know how far we'll get with the whole project. Hopefully we can have some sort of finished system by the end of the month that has all these different components at least semi-working. But yeah, again, I'm not exactly sure how much will be built out. Yeah, one more thing is I'm mainly going to be focusing kind of the backend side of everything. I don't have much front-end experience. I don't really have any front-end experience at all, except for writing a website once using Bootstrap, and so that's also what we'll be doing from the front-end side. So I think I will be making some assumptions also in our data models, or maybe we'll see, that hopefully someone who's good at front end can implement the stuff even if I can't, or also if that is something that can't be done on the front end side, then there would be someone else to kind of give feedback on those things. And then we can find a better solution together. So yeah, everything here is mainly from a backend perspective, because that's generally what I've been exposed to the most, even though I specifically actually come from a data perspective. But yeah, so before I jump into any of this though, my internet connection is sometimes not the best, so I want to pull this up real quick somewhere else, and I just want to see like the quality that's going out, because I may have to actually reduce the resolution because our upload speed is not very fast at all here. So yeah, um, bear with me here while I'm just going to go onto YouTube on my phone. I'm gonna try to find the stream and just see what everyone else is seeing, um, to see how the quality is like. So we're gonna have a short pause while I try to find this. Okay, I mean that seems okay. I was generally afraid that it would be buffering or something because that's, some of the warnings that I got from YouTube. But it seems to not be buffering too heavily, so that's pretty great. So yeah, with that, I think basically want to show you kind of what I've done so far. I'm using Miro for this for no particular reason except that I used it before and I quite liked it in the sense that like I can scroll in and out and I can just basically add stuff on here and have this really big brainstorming map that is really useful because I don't really want to be constrained to like pages or something, and I want to have everything, I want to be able to have everything in an overview without necessarily being limited to some sort of document structure. And so I think for me, I really liked Miro when I previously used it, so I decided to use it again. For a general, very high level overview of what I want things to look like, and this is obviously going to evolve a lot, is generally we're going to have some sort of client, which is, in our case, always going to be a web application. I'm not thinking about mobile in any way right now, because I also don't have any experience with mobile, but I assume that, we're going to have our application here, and so the way that the client will interact with the application will be very similar, so I don't really want to worry about any of this stuff. Our application here, what I'm hoping about doing is I'm going to build the kind of base using Flask, and then I'm going to probably have the endpoints in there at first, but then hopefully move them out as like small microservices, so that we can have different services for different things, and basically our Flask application will be kind of just sitting there and help with rendering the pages, and then just going on to different microservices to kind of fulfill the requests. This is also a structure that I think I have to look up a little bit more because I've never done the core base of a site, working on different services or different features, but never building the main running core thing. So this is definitely something I also want to look up, that maybe is this the right approach, but generally the way that I'm thinking about it is, if you're building a monolith, which a lot of companies had, or a lot of them also still do have, they're trying to migrate away from that. This is generally how I imagine that they would start with it, just having like a big massive application that's kind of deployed. And so the way that I'm thinking about this is, well, okay, let's take a monolith, but let's already think about just extracting away some of these endpoints into different microservices that can help us with some of the things. So I'm just kind of like, as I was thinking about it, I just kind of listed out the base stuff. Again, right now I'm not super concerned about this because this is something that I'll get into a little bit later. But generally I was thinking, okay, we need to have some sort of login because I don't want users to be able to post or comment or even upvote without being logged in because, for one, it makes tracking more difficult. And also like deduplication, anti-fraud, it'd be very difficult, I think, to basically fight against like upvote spams or downvote spams if a user is not logged in, because the deduplication mechanism will be much more difficult to work around. So for that, we want to log in a component, and obviously having an account is kind of a standard thing. We want some sort of homepage, and the way that I imagine this homepage is just like a list of posts. I don't really have much of a vision for it yet, except for just some sort of list of posts. And the homepage probably will like have different features, just like Reddit does, with like new, hot, top, those sorts of things. And depending on the selected filter, we can probably have different entities kind of responsible for helping render those things. But I don't think I'm going to worry too much about that because that is getting so much more into, like building specific features and, trying to build some sort of like recommendation thing. And I just want to keep this simple to like building out the base application. and not get lost in any one of the like specific feature details. The other thing, obviously, that we want to have is some sort of like subreddit or some sort of like subsite where we can go to like some subdomain, and from there we can basically, again, just have like a similar view of the homepage, but obviously this one is specific to that specific site. And that's going to be spread up into posts, which is what we'll see kind of on that first layer. Same thing that we'll see here. And then once you go into a post, oh, this is not correctly connected. Once you go into a post, from there you can then get into a comment thread. We will generally want to assume that it will be some sort of thread, as it often becomes. So from here, we'll also be able to see this sort of stuff. Okay. So yeah, this is like generally the structure that I'm thinking about. Obviously, there's a lot of stuff missing that I think as we kind of, oh yeah, the one thing that I kind of skipped over is like, we can technically have like an edit and view account, but like, honestly, I'm not super concerned with that because no one's going to be using it. So I don't see any reason for someone being able to change their username, change their password, change anything, because no one's going to be using it. So I don't really want to worry about building this thing out because it's not really, I mean, again, like a large part of this is, like learning for myself too, and building out an edit or view account page isn't really that much of a learning experience, because all you do is you just render a site and then you can send a request and then that updates some information in the database. So it's not really exciting or to build. So, obviously you'll probably have something like that, but I don't really want to worry about that. Yeah, so what you've seen here also is pointing to a bunch of different databases, or two different databases. Generally, there is like a Postgres and some sort of Redis. I am not at all, or I kind of have now, but when I was building this out, I did not decide on it at all. I just wanted to kind of leave like a mental note for myself that I need to connect to some sort of database, and I also need some sort of cache. And figuring out what this database is, what the schemas look like, is what actually happens down here, which we'll also walk through in a second. And then we'll also have this cache component here, because it's extremely important for us to have a really good cache, because otherwise we'll be hitting our database all the time, and well, our service is not going to be able to scale as well because our database is going to be the main bottleneck. So we always want to think about our cache, because it will, save us in the long run. But obviously, thinking about our cache, we also need to think about limitations of like the way that we're building our cache, so that we can make this like hyper scalable, or at least like trying to keep some of those things in mind. So generally for logging in, this is something that I don't really see a cache for, just because, I mean, you probably could have a cache for it, but I'm not really thinking about that right now, just because like when you log in, we will have a single like request that either confirms that the password matched and then you get logged in. Similarly with like the edit view account, I'm not really expecting like high load here, but obviously, we could also put like a cache here so that basically we cache some sort of like username and password combination, obviously the password being hashed or something, and then we can compare that to our cache, and otherwise we go to the database. But yeah, this is kind of the only place where I didn't really see the need for a cache, at least initially, but obviously this can be relatively easily extended to also just cache the things that are most often requested. For our homepage and everything, the need, as well as for like individual posts and common threads, the need is obviously much greater, because people will be seeing the homepage many times, especially if it's just like a generic homepage like new or hot or top, without being filtered by anything. So obviously having a cache with that, because we'll basically be serving the same response a bunch of times. And for each post, we also want this cache, because we don't want to have to reload a post from scratch, because if a post is kind of going on right now, it's likely that a lot of people will see the same post, and so it'll be much better to go to our cache for that rather than having to go to our raw storage or our raw database. And similarly, common threads, especially, if a post gets going, you don't want to go to your database to just reload comments all the time, but hopefully we can also like get those things from cache, again, to kind of reduce the load on our database. Our database is mainly always going to be like disk-based, whereas our cache is mainly always going to be memory-based. And so we can obviously serve a lot more requests from our cache because it'll be serving a lot faster, and we definitely want to avoid going to our database unless necessary, just to, just in case. So yeah, going over our database tables, and you can actually see here, I considered like different databases, and not initially for the accounts and followers, but like when you think about like posts and comment threads and subreddits, like generally, if you've ever heard of a graph database, which I have, and I haven't really worked so much with it, actually I haven't ever worked with it, I haven't ever needed to work with it, like you feel like this is the right place to do a graph database. And so obviously I think this would be a cool thing to do. However, the more I thought about it, the more I thought, well, this, if I do it with a graph database model, and this being the first like the first kind of larger project to actually build out with like a graph database model, this is going to be just a graph database like modeling and querying and like setup exercise for me rather than like building out of the site. And so actually I had decided, even though a graph database would probably be the best fit for this because of like this graph-like relation with everything, I'm not going to use a graph database because if I want to practice graph stuff, which I definitely want to do, and maybe if there's time at the end, again, I have absolutely no idea, then I can actually rework some of this to maybe work with a graph database to kind of get that practice in, or I'll just take some time whenever just to kind of practice redoing the stuff that I did in another database, except using a graph database. But yeah, the main point of this is just to try to build out an application and do as much as possible. So then other options come to mind. You can have a document store like MongoDB, because if you think about like comments and especially posts, those will be like some sort of document with like probably a lot of text at times. Other things that I was thinking about were Postgres, just because Postgres is such like an easy thing to go to, or SQL in general is very easy. It really depends on like what your background and your preferences. If you worked a lot with MySQL, you'll probably tend to that. I've worked a lot with Postgres, so I generally go towards Postgres. But it's very easy, in my opinion, to like define database models with Postgres, or just in general like define SQL models. So obviously like Postgres is generally always going to be my first choice when I'm designing, just because it's the easiest for me to define database models, and I feel like they're easily extendable from like an SQL model to like other models, so I don't really see like a lot of loss going on there. But as you'll see in a second, I also wanted to consider other things. So for example, I wanted to consider Cassandra, just because like Postgres comes with a lot of stuff like the ACID transactions, and also being able to do like aggregations and joins and the foreign key links, and a lot of that I don't think is like absolutely necessary. I don't think we'll be doing a lot of aggregations, or ideally I want to avoid doing a lot of aggregations, because that will just like put more load on our database, which I don't want to do. So I want to do as much as possible to avoid that. You can make noise, by the way, it's totally fine. Bebo, you can make noise, it's totally fine. Just started the streaming of the thing.
Are you live?
Mm-hmm.
Is the camera on?
Yeah. Should I turn it off? Okay. So yeah. So the other thing was going to be Cassandra, because I think Cassandra is we're having like a NoSQL schema, or having a NoSQL database and using the Postgres-like schema, because that's really what I was after, just the nice schema that we have from Postgres. Cassandra kind of fits that nicely because we're able to write and read very efficiently from it, and we don't really need like join operations, because the way that I was thinking about the site coming to live is basically in like stages of comment threads, so that we would load like the first thread of comments, and then when someone expands one, then we could load that subsection. And so we don't really need a lot of joins, and I really like want to avoid joins because I feel like those can cause a lot of problems. So ideally, we just have like a read and write where we have like filter operations without any sort of like extra aggregations going on or any sort of like extra more heavy database stuff to avoid load. So Cassandra is generally like a kind of like the way I see it is like a nice alternative to like an SQL model, because you have like this SQL like table and stuff, but you don't necessarily need like the stuff that you get from an SQL database, like specifically the ACID transactions, as well as these aggregation and like these join operations and stuff like that. And we don't really need that, and I kind of want to avoid that, which is why I thought about Cassandra. And with Cassandra, it would be interesting because we can basically just have really large tables that we just kind of heavily read and write to, and it'll be great for kind of putting individual transactions, in this case like posts and comments, and even like other sorts of events in there. But there was a problem that I ran into when I was thinking about Cassandra, which is thinking about how to keep track of IDs for different comments and for different posts and stuff like that. Because something that's really nice about Postgres is you have this like serial data type where you can insert into the database, and then you have an ID created for you. Whereas with Cassandra, I basically kind of need to abstract that logic away somewhere, because I don't think Cassandra has a serial data type. So when we're inserting data, I want to be able to refer to things by their IDs. So I want to be able to like pull up a post by its ID and load the top level of comments for it and load the upvotes and downvotes and stuff for it. So yeah, I want to be able to have that ID, and I want it to be able to have it easily. And if it's not directly supplied by the database, that means I have to have some sort of different entity that is responsible for keeping track of different IDs, which means that we now have two things that we need to worry about. One of them is our database consistency. The other one is the IDs, and just making sure that there's these two connected components are always working properly. And yeah, thinking about it, that seemed like a real headache because when a lot of comments are going on, you need to make sure that you don't reuse the same ID, and that means basically we need to have some sort of like locking mechanism around it, which will affect our scalability if we have like a single comment ID like location that we're pulling from, or we could split this up into different levels, which would be like a common ID per post ID, or like a common ID per site ID, depending on like how we want to partition this. But that means that our table will also be growing in that size. And there we will be doing a lot of like update operations because we're always incrementing our IDs. And so then we need to persist that data somewhere. And so then we need to worry about a different database, or at least a different data table, where we're persisting all of our ID increments so that we can restore all of that in case of failure. So you can see how that, gets to be a lot more of a headache. It doesn't mean it's like the wrong solution. It probably may, I don't know if it's a better or a worse solution. I would need to spend some more time thinking about it, and probably also talk to some other people about it, because I've never built a system with that way, like having the IDs thing just separate, and really trying to think about like the edge cases of what happens under high load or how things can break. So yeah, I don't really want to worry about that too much. And so I do think a Postgres data model can do the job for us, but I'm going to do the model in such a way that I can avoid, ideally, joins and aggregations whenever possible. Although it would have been nice to, like have Cassandra for that, where we can just do like a lot of reads, because again, we don't need any sort of join information or anything. So I think Cassandra would have been really cool to use. But again, thinking about like keeping track of all these IDs and stuff just becomes like a whole nother headache, and it'll probably just expand a lot of the dependencies and a lot more planning to make sure all of that stuff is consistent. So yeah. Generally, okay. Also, so I started doing this all yesterday. This whole thing, I think it took around like 3 to 4 hours, because I did a lot of like back and forth about the data models that I wanted to use, and I looked up different databases and I tried to find some examples. You can see here, like I looked up like a bunch of different things, and I will continue to do that. And obviously part of that is also just like reading documentation of different databases. Because initially I was really excited to use like the graph database, and so I started reading like the Neo4j documentation, but then I was continuing reading, and I thought, well, if I want to do it this way, I just need to read all the documentation first so that I can build this out properly and practice the queries and build proper data models and have good sample queries. And so I kind of stopped that like halfway through. So that was a pretty big time sink that was kind of included in here. And then a lot of other stuff was just, Googling and stopping and thinking about and updating the models and trying to adapt it to like a different database schema. And just like a lot of iterative work. So yeah, I mean, generally like going through the database models, they're pretty simple. Like user model and like a user site follows. So just to understand like what sites the user is following so that we can kind of curate a homepage for them. And then we get onto the kind of site level. And these should probably actually be different levels, but whatever. We'll plan all this stuff out a little bit more rigorously maybe, but not necessarily. So we have our site level here, and our site is just going to contain like the name of the site and when it was created and if it's alive or not. So it's basically just going to be like information about our subreddit. And like we can obviously expand this data model to include information about like a description and stuff, but that to me isn't like a main priority. Like adding extra metadata is not really something I want to worry about right now, because that's, database models are easily extended in that way. Admins for the sites. Then it comes the most important things, which are the posts and the comments, because this is the things that are most heavily going to affect our performance. And so our posts are going to be for like posts with an individual site. They're going to have titles, authors. They're going to have some sort of content. We're going to have a flag if they're alive or not, like if a post was deleted or not, because just because a post was deleted doesn't mean we can't show the comment thread, because if we delete this, we would otherwise have to search and delete everything in here. And I was thinking about doing like a likes and dislikes counter, but I don't want to do that because that will be a ton of update operations on our database. And so, yeah, actually I'm just going to take this out right now because I don't think likes and dislikes will be a good thing to have, because again, like if a post is going off, we will have a ton of update operations, and that's going to be really bad for our database. So that information needs to be elsewhere, and it's going to be in our cache. And we're also going to track it in like events, which I'll get to in a second. Then we have our comments. Our comments are also going to have an ID. Obviously, they're going to have timestamp when they're created, a title, an author, the content, the post ID that they refer to, as well as the parent comment ID, and if the post is deleted or not. The parent comment ID is going to be so that we can always filter for specific parent comments. And I'm actually going to set this to not null. Because if a comment does not have a parent, I want the ID to be 0, because that is kind of like a nice consistent thing that we can use rather than having null values, because null values, depending on where you are, may be treated differently. So just having 0 here will be a nice thing to have. And then we'll have the parent comment IDs, and basically we can always filter on parent comment IDs to get all the children, and then we can just, work on like rendering it layer by layer by layer as you're expanding into comment threads, rather than having to worry about building out everything as a whole. And then I was also thinking about like, how can I do this in Cassandra? And I started building out, the main difference here, because so much of the schema is actually the same, all the schema is actually the same except for like foreign key references and stuff. The biggest information here would be in the primary key and the clustering order, to allow more efficient fetching of what we want, which is generally always is going to be the most recent ones first. So our primary key, basically just thinking about uniqueness, primary keys here and primary clustering keys. But then I started thinking about, okay, how am I going to get this ID information? And then we came to the whole problem of having different service or a different database entity and service that needs to worry about generating IDs, and that just became a whole big thing that I did not want to deal with. And then we have events. These events, well, first I thought about like extracting them away into just like a metadata events type table, and then just like events on a post. So events on a post could be things like upvotes, downvotes, shares, not comments, because comments have their own separate table, but generally things like that. And so for that, well, my initial thought was I want to have like an event ID column here, and I probably want to make sure like all of my naming is consistent, or my naming structure is consistent. So I was like, okay, I'm going to have an event ID column first, and then, I can have that metadata information on the event types, and I can resolve all that stuff. But the more I thought about it, the more like I thought this isn't really going to benefit me very much, because if I think about, okay, what kind of events are we going to have, what kind of names, we're going to have things like upvotes, downvotes, share. Those are like the main ones that I can think of right now, but even, other ones are probably not going to be super long in name. And so thinking about the name like downvote, which here would be 8 bytes, whereas if we have an event ID, which would be an integer, which is 4 bytes. So we're basically storing 4 bytes extra information, but I don't need to worry about ever joining onto another table. And if we have 4 bytes and we have like, what would it be? A billion events in here or something, that's going to be like 4 gigabytes. So, or not even really, but just under. So, it didn't really seem worth it to worry about the event ID here. Similarly, I want to think about the naming structure here. We have the same thing for comments, like likes and, upvotes and downvotes mainly, as well as share things. And let's see, I think this is probably wrong. You can see copy paste errors. Oh no, this is correct. We want to know what post is referenced, but this is wrong, because this is supposed to reference comments.id. And then I just have like a general field for an event value that may or may not apply. So I think in the case of like upvotes and downvotes, this field is actually going to be empty. But for things like share events, we're going to have some information here that we can use to resolve this. And mainly I'm doing this because like right now I'm just thinking about upvotes, downvotes, and shares. I think if there was, like a whole product plan and designs that we can go off of, then maybe we would need to rethink this. But, I don't have like designs or anything. I'm just kind of like building it off of memory. And so for me, like really the 3 main events that I see are these ones. And none of these will include like user events, obviously aside from like upvote and downvote and share, but like clicking expand or those sorts of things, or clicking into a post, or all of those user events are not going to be tracked in here. And then obviously we need to start thinking about indexes at some point. I started doing a little bit, but then I stopped, because that's something that, I can do later, and just easily add a new index, based on how I'm planning on using each of these tables. But the nice thing about this, I think, is hopefully I'll be able to avoid any sorts of like aggregations or joins or anything, because we'll be able to load things like layer by layer. So for example, if we go to our homepage or our subsite, then all I need to do is I just need to query from the posts filtering on the site ID and nothing else. So it's basically just like read operations. And then if we go into a post, all I need to do is I need to filter by the post ID, and initially the parent comment ID is just going to be 0 to get the top layer of comments. And then if we go and expand into a common thread, then all I need to do every single time someone clicks open on a new common thread, just generate a query filtering on that specific comment thread. So we're basically going to filter by parent comment ID and post ID. So we're always going to be doing select filter queries, and basically going like just about reading and writing and trying to have sort of like an append only system, so that we don't need to worry at all about like updates or joins or aggregations or anything. Yeah. Then, okay. So the other thing, and I started taking like a bunch of notes for myself here about how I want to build things out so that I don't need to forget, and also just writing out my thought process so that I can help make some of these decisions. But so for example, one thing that will happen is we're actually going to have like some sort of pipeline where we will have, when an event comes in, like, and that can be any sort of, I don't even want that. So that can be any sort of event, but let's, for example, have it be like an upvote on a comment. So what I want, when an upvote on a comment happens, I want to basically hit a specific service for it. Or basically like some sort of service that will take care of the events. And this is going to, and I'll replace this with like logos in a second. This is going to go into, into some sort of Kafka stream. And from the Kafka stream, I then want consumers that will consume specific events. This will be separated based on topics, and each topic will have partitions. I want these consumers to be able to start consuming this stuff. And then, for example, on an upvote on a comment, so what we need to do here is several things. First, we need to actually insert that into the database. Then we need to update that in the cache. So I want to store some sort of order in the cache so that we don't need to go to our database to understand like what are the top rated comments, but rather we should be keeping that in our cache so that we basically have for every single like comment thread, whatever level it's at, we can go in there, and whenever an upvote happens, we go into that comment thread, which will be stored in Redis currently, because that's kind of what I'm familiar with. And we will access a list of values, and that list will then contain information. Every single element will be an ID, as well as the current like upvote, downvote, like sum. And then we will just increment that value by 1. And if that changes the order of it somewhere else, then we're going to just change the position of it too. So we need to update it in the cache. And let's see if there's anything else. There was one more thing that I was thinking about that I now kind of forgot. Hopefully I'll remember it later. Let's see. Yeah, I don't know. I forgot. But maybe we'll probably get there at some point, or we'll notice it at some point that there may be one more thing that we need to do here that I felt like there was a third thing, but now I just forgot. But yeah, so basically we need to be able to do these things, and actually I think what's really important for us is that we need to also like layer this in some way. So the inserting into the DB needs to happen first. And only once something has been inserted into the database can we actually go about updating the cache, because we don't want our cache to be updated and our DB insert to fail. So if we split this off, then I don't want to be like, oh, okay, well, our database has been updated, our database update failed, but our cache update succeeded, because that's not what we want at all, because that's going to basically make our cache inconsistent, and it's only going to be consistent when we like recompute that part of the cache, which we ideally don't have to do. So yeah, probably we'll have that inserting into the B kind of be that first stage, and then we'll put it into a different Kafka topic to basically say like these things have been updated in the database, and now you can go about updating caches with them. Yeah. Then okay. So that's kind of generally how I see the flow going, is we're going to basically always be relying on Kafka for these things. inserting it into Kafka, and then I haven't really thought about like the topics that I want to use that yet, but trying to use appropriate topics and appropriate partitions so that we can start adding consumers to all of these things, so that we can basically scale out if load begins to increase. At the same time, like something that we need to keep in mind is when we're updating the cache value for a specific like comment thread, then, or for a specific comment as well as the comment thread. So yeah, I think here I need to expand this a little bit. And here it will be, so we need to update it in cache, and we need to reference from the parent comment ID, because the way that I want the cache to be, and you'll notice that generally the way that I'm going to be going about this is some sort of like free-form thinking as well. Right now I'm just trying to catch you up on the things that I did yesterday. But the way that I want our storing to be, I think, is going to be this nested structure where we basically, I don't know if hset is going to be the right thing for this. I'll have to test this out. Maybe we'll do a set, but I feel like I want to do an hset for this, but I want to make sure that I can get the proper order here. That our key here is going to be the parent comment ID, and then each child value is going to be a tuple that's going to have the child comment ID as well as the absolute number of upvotes. So it's going to look like ID and votes. That's what our values are going to look like. And so obviously if a lot of the stuff is going on with the same parent ID, we need to lock around this, or we need to do it with a single service. But either way, we need to have some sort of serial stuff so that we don't encounter race conditions, so that two different entities are updating this at the same time, and basically one of the updates is lost. So that will affect how much we can actually scale this. And yeah, I think doing this on like a parent comment ID level will be appropriate. And when things, like go really, really big, then we may run into like some slowing down here. But, we need to be very careful about race conditions. And I feel like this is going to, it probably won't scale to infinity, because we actually can't. We're like, at some level, we're like serial. And this really just depends on the key that we're choosing, because each key has to have a serial operation here to avoid race conditions, or we'll lock, but locking makes it serial. So this is going to be like our rate limiting factor that we cannot scale out of. So we can't just horizontally scale and add more consumers, because we're locking essentially. So that is going to be our like bottleneck here. But I feel like this should be okay if we do this with like a parent comment ID. And the nice thing about this is that the other thing that I want to be careful about is when one thing is like blowing up in theory, I don't want this to affect the performance of the rest of the site. And so that means if we have one like post, and then in those posts specific like comments are like blowing up, then this part of like the consumer process will be slow, but it will only be for that specific site, and maybe for that specific post, or maybe even like only a subset of comments on that post, and the rest of the site should hopefully be functioning normally. So yeah, we don't want one like mega thread to take down the whole site. We want to be able to like separate that away. Yeah. Okay. Yeah, so this is kind of like the general idea of like passing this information through Kafka, so that we can deal with these. Obviously this will be like a real-time but I'm not super we don't even necessarily need real time. Like we can do like batch updates, or like mini batch updates, where basically like if 5 upvotes come in at the same time, we don't need to process them one after the other and then put those into the database and change the order. Like there's no reason why we can't have like a small time window to aggregate all those things together and then just do it in one operation. Because although it will introduce a little bit of latency, it's really not that important. And it may be better for our performance long term when we're batching these things together, because that basically reduces the network round trip time, because instead of doing like 5 network requests, or actually 10, because we need to get the results, we need to make all the changes, and then we need to update them. So for every single thing, we would actually have two round trips. So if we batch those together, we will just reduce those. So we can go from, if we're doing in like batches of, we probably wouldn't do like batches of 5, but we do like a 5-second batch or something like that. Then we'd be able to greatly reduce the amount of round trips, which can actually have really nice impacts on the performance, because things are just speeding up. Because we spend a lot less time waiting for a network things to happen. So the threshold that we probably need to get to, how fast things are coming in, will be higher because again, we don't need to wait for that network stuff. And I started writing about out some important questions. So how do we deal with one post being extremely high volume? That's kind of what I just talked about. I want to have some sort of TTL in the cache fields. Just these are important questions / notes for myself to think about. So I want to have some TTL in the cache, and generally I think having something been accessed from the cache for a 1-day time interval, I think may be good. Maybe it'll come down to 12 hours. I think this really depends on the scale. So I think, for one, you can obviously always increase your cache to cache more, or if your site is getting really, really big, then more users are going to be accessing things more frequently. So you can actually reduce your TTL, and basically whenever something is accessed, you just reset it. So maybe right now I was thinking of a 1-day default, but this could go down to 12 hours or 4 hours or something, because if no one accessed something on a very active site for 4 hours, that probably means it's not that important to keep in cache. But obviously this is contextual on everything else around it. And in our case, when there will be no users, a cache of 1 day will be fine, also because there will be not a lot of data to cache, and the traffic will be much less, so it's much more likely to have longer periods of downtime. I really want to be careful about double counting and misaggregation. So that's just something to keep in mind. A lot of new post flooding, and that's the same thing with high volume. We also want to make sure that we don't drop events. Obviously there are different places where we can drop events. And if something never goes through, if someone posted a comment but it never actually went through, then that will be a place where we drop events. But the other thing that hopefully we can take care of this with is that once we reach this stage, then we basically want to make sure our data is persisted as fast as possible. So yeah, that's really important for us. Or that if it's not persisted, we give some sort of information that actually was failed to cache, or actually to persist. So the other question is could we get a consistent view of the common thread breakdown? This is actually kind of interesting, because I don't really think we need a fully consistent view. The only thing that we need is a consistent view for our user. So if we have multiple, if at some point we go into having multiple read replicas, so maybe we have a write head, and then maybe we even just have one read replica, or no, we'll have 2 read replicas, just to kind of illustrate this. If we have 2 read replicas, these don't necessarily need to be at the same state, or at the same they don't need to be at the same state. But the most important thing is that the user sees the same thing. So I don't want the user to see comments and then see them disappear and then later see them come back. So basically we want our user to have a persistent connection to the same read replica, so that their state is always consistent, even if it may not be consistent with a full common thread. Obviously this will only apply when there's extremely high traffic, and then there will be small delays. But yeah, that's also why I thought about Cassandra, because we don't really need the strong consistency that an asset database provides. Instead, eventual consistency is fine as long as the consistency is as long as the user is seeing the same thing. So we just need to maintain that connection, or use the same database connection for that. Yeah, mini batch updates, what I talked about. Materialized views, I was thinking about that, but that's not going to be an option because I actually looked up